Our solar system is a fascinating place, full of wonder and mystery. It is a vast expanse that stretches across unimaginable distances, filled with planets, moons, asteroids, and comets. Each component plays a unique role in the cosmic dance that defines our celestial neighborhood. At its center lies the Sun, a star that provides warmth and light to all the planets orbiting it. This massive, glowing sphere is the heart of our solar system, radiating energy that sustains life on Earth and influences the environment of every planet. The Sun is a giant ball of hot gas, mostly hydrogen and helium. These gases undergo nuclear fusion in the Sun's core, producing immense amounts of energy. This energy travels outward, eventually reaching us as sunlight and heat. It is so large that over 1 million Earths could fit inside it. To put it in perspective, if the Sun were a hollow ball, you could line up Earth side by side, and it would take over 1 million to fill the Sun's volume. The Sun's gravity holds everything in our solar system together, from the smallest asteroid to the largest planet. This gravitational pull ensures that planets, moons, and other celestial bodies follow their orbits, creating a stable system. Without the Sun's energy, life on Earth would not be possible. The Sun's rays provide the essential energy that drives photosynthesis, the process by which plants convert sunlight into chemical energy. Plants use sunlight to make food, and animals in turn eat plants or other animals that eat plants. This energy transfer forms the basis of the food chain, supporting all life forms on our planet. The Sun also influences our weather patterns and climate. Its energy heats the Earth's surface, causing air and water to move, which in turn creates weather systems and climatic conditions. Its energy drives the wind, ocean currents, and the water cycle. The Sun's heat causes water to evaporate from oceans and lakes, forming clouds that eventually release rain, sustaining ecosystems and replenishing water sources. The Sun is a powerful force in our solar system, shaping and influencing everything within it. Its presence is a constant reminder of the delicate balance that sustains life on Earth, and the intricate connections that bind our solar system together. Mercury is the smallest planet in our solar system, measuring just about 3,032 miles in diameter, which is roughly 1/3 the size of Earth. Despite its small size, Mercury has a significant impact on our understanding of planetary science, and the closest to the Sun, orbiting at an average distance of about 36 million miles. This proximity to the Sun means that Mercury experiences some of the most intense solar radiation in the solar system. It's a rocky planet, much like our Moon, with the surface covered in craters. These craters were formed by numerous impacts from comets and asteroids over billions of years. The largest crater, Kyer Basin, is over 960 miles wide. Mercury is named after the Roman messenger god, known for his incredible speed. This name is quite fitting, given the planet's rapid movement across the sky, which has been observed by humans for thousands of years. This is fitting because Mercury travels around the Sun faster than any other planet, completing one orbit in just 88 Earth days. This rapid orbit is due to its close proximity to the Sun and the strong gravitational pull it experiences. A year on Mercury is only 88 Earth days long. This means that if you lived on Mercury, you would celebrate your birthday 4 times more often than on Earth. Because it's so close to the Sun, Mercury experiences extreme temperatures. The side facing the Sun can become incredibly hot, while the side facing away from the Sun can become extremely cold. During the day, the surface can reach a scorching 800 degrees Fahrenheit or 430 degrees Celsius. This intense heat is enough to melt lead and is one of the highest temperatures in the solar system. But at night, temperatures plummet to a frigid minus 290 degrees Fahrenheit or minus 180 degrees Celsius. This drastic temperature change is due to the lack of a significant atmosphere to retain heat. Mercury has a very thin atmosphere, which means it doesn't have weather like we do on Earth. This thin atmosphere is composed mostly of oxygen, sodium, hydrogen, helium, and potassium. There are no clouds, wind, or rain on Mercury. The planet's surface remains barren and unchanged, providing a stark contrast to the dynamic and ever-changing weather patterns we experience on Earth. Venus is often called Earth's twin because it's similar in size and mass to our planet. Both planets are nearly the same diameter, and their masses are quite comparable. This has led scientists to wonder if Venus might have once been more Earth-like, perhaps even harboring oceans and life. It's also a rocky planet and it has an atmosphere, but unlike Earth, Venus's atmosphere is incredibly dense and composed mainly of carbon dioxide with clouds of sulfuric acid. This makes the surface pressure on Venus about 92 times that of Earth, equivalent to the pressure found 900 meters underwater on Earth. However, that's where the similarities end. The conditions on Venus are extremely harsh and inhospitable. Venus is the hottest planet in our solar system, even hotter than Mercury, despite being farther from the Sun. The average surface temperature on Venus is around 900 degrees Fahrenheit, or 475 degrees Celsius, which is hot enough to melt lead. This is because Venus has a very thick atmosphere made mostly of carbon dioxide. The dense atmosphere creates a runaway greenhouse effect, trapping heat and causing the surface temperature to soar. This runaway greenhouse effect is so extreme that it has turned Venus into a scorching inferno. The heat is trapped by the thick clouds, making it impossible for the planet to cool down. The surface temperature remains consistently high, day and night. Venus rotates very slowly on its axis and in the opposite direction of most planets. This means that on Venus the Sun rises in the west and sets in the east. A single rotation takes about 243 Earth days. A day on Venus is longer than a year on Venus. It takes Venus about 225 Earth days to complete one orbit around the Sun, making its day longer than its year. The surface of Venus is covered in volcanoes, mountains, and vast plains. These geological features suggest that Venus is still geologically active. The planet's surface is relatively young, with evidence of volcanic activity that may have occurred in the recent past. This makes Venus a fascinating subject of study for scientists who are trying to understand the geological processes that shape rocky planets. Earth is our home planet and the only place we know of that supports life. It's a rocky planet with a diverse surface of oceans, continents, mountains, and deserts. Earth's atmosphere is a unique blend of nitrogen, oxygen, and other gases that protect us from harmful radiation from the sun. The presence of liquid water on Earth's surface is what makes our planet so special. Water is essential for all known forms of life. Earth's temperature is also just right for life to thrive, thanks to our atmosphere and the greenhouse effect, which keeps our planet warm enough to support liquid water. Our planet has one moon, which orbits Earth and influences our tides. Earth is a dynamic and constantly changing planet with a fascinating history and a bright future. Section 5, Mars, the Red Planet's Mysteries. Mars has always captured our imaginations. It's a cold, rocky planet with a thin atmosphere. Mars gets its distinctive red color from iron oxide or rust on its surface. Scientists believe that Mars may have once been a much warmer and wetter planet than it is today. Evidence suggests that liquid water once flowed on Mars, and there may have even been oceans. Today we find evidence of water ice at Mars' poles and beneath its surface. Mars has two small moons, Phobos and Deimos, which are thought to be captured asteroids. Section 6. The Asteroid Belt, a cosmic highway. Between Mars and Jupiter lies the Asteroid Belt, a region populated by millions of rocky objects called asteroids. These asteroids are leftovers from the early solar system, remnants of material that never quite coalesced into a planet. Asteroids vary in size from small pebbles to dwarf planets hundreds of miles wide. There is a dwarf planet in the asteroid belt, however. Its name is Ceres. The asteroid belt is not as crowded as it might seem from depictions in science fiction. While there are millions of asteroids, they are spread out over a vast area of space. Spacecraft traveling through the asteroid belt have to navigate carefully, but the chances of a collision are actually quite low. Section 7, Jupiter, the giant of our solar system. Jupiter is the largest planet in our solar system, a gas giant with a mass greater than all the other planets combined. Jupiter is composed mostly of hydrogen and helium, similar to the Sun. One of Jupiter's most striking features is its Great Red Spot, a giant storm that has been raging for centuries. This storm is so large that 3 Earths could fit inside it. Jupiter has a faint ring system, much less prominent than Saturn's rings. Jupiter has dozens of moons, each with its own unique characteristics. Section 8, Saturn, the ringed wonder. Saturn is best known for its spectacular ring system made up of countless particles of ice and rock. These rings are incredibly thin despite their impressive width. Like Jupiter, Saturn is a gas giant, composed mostly of hydrogen and helium. It's the least dense planet in our solar system, meaning it would float in water if you could find a bathtub big enough. Saturn has numerous moons, including Titan, which has a dense atmosphere and methane lakes on its surface. Section 9. Uranus and Neptune. Ice giants in the dark. Uranus and Neptune are the ice giants of our solar system. They are similar in size and composition, made up mostly of water, methane, and ammonia ices. Uranus is unique for its tilted axis of rotation, which causes it to orbit the Sun on its side. Neptune is known for its strong winds, the fastest in the solar system. Both Uranus and Neptune have faint ring systems and numerous moons. These planets are difficult to observe from Earth because of their distance, but they are fascinating worlds with much to teach us about the outer reaches of our solar system. Section 10. The Kyer Belt. A distant realm. Far beyond the orbit of Neptune lies the Kyer Belt, a vast and icy region populated by dwarf planets, comets, and other icy bodies. Pluto, once considered our 9th planet, is now classified as a dwarf planet and resides in the Kyer Belt. Many more dwarf planets reside in the Kyer Belt, like Haumea, Makemake, and Eris. The Kyer Belt is thought to be a remnant of the early solar system, a repository of icy objects that never coalesced into larger planets. Studying the Kyer Belt can provide valuable insights into the formation and evolution of our solar system. It's a region of intense scientific interest, and future missions may reveal even more secrets about this distant and mysterious realm. And that's the solar system, all the way from the Sun to the Kyer Belt. It's much bigger than you think. Until next time, guys, please subscribe so you never miss any new fascinating space videos like this one. Peace out.